Huh. Hello and welcome to Math 1000. This is the finance lecture. I am Bo Corkins and I will be guiding us through this wonderful, wonderful material regarding finance. So, some basic things to start with, and we've already talked about a little bit of this, right? Percentages. When dealing with percentages mathematically, we have to deal with decimals. All right, you cannot deal with 100% as that value. You have to turn that into 1.00. General concept of percentage is that it's the subtotal divided by the total. All right, that gets the decimal, and then you multiply it by 100. Looking at an example there. All right, so I have a graph that shows the sales in thousands of the top 5 selling cars in '06. Ford Focus, Honda Civic, Ford Taurus, Honda Accord, and the Camry. So, what percent of sales of these 5 cars was due to the Toyota Camry? So, in order, we want to find the overall total, which is just adding up all the cars, right? So that gives us 1767. All right. And then in order to find the percent of sales, all right, of the Camry, well, that means we have the 423, all right, divided by 1767. Now, I highly recommend 4 decimals because when, all right, you have 4 decimals, then when you convert this to a percentage, when I multiply this by 100, that becomes 23.94%. The big thing here is that then you always have 2 decimals in percentage. Now, in I'm all about real world commonplace rounding. And 2 decimals is basically the number we round everything to because that's what money is. Since money is 2 decimals, then we always want to have 2 decimals. But when you have a probability here, make sure that you have 4 decimals. So when you get to percentages, you have 2 decimals. What percent greater was the sales of Camry than the Civic? So, couple of notes here. Percent increase and percent decrease. These are the two cases where you can go above, all right, like 100%. Because percent increase, basic concept here, it is the big number divided by the small number minus 1. Percent decrease is 1 minus the small number divided by the big number. So, and when we say percent increase or percent decrease, right? Percent greater, percent more, percent, right? Improved concept. Percent less, percent smaller. So any synonym of increase and decrease. So what percent greater, right? That means percent increase. Was the sales of the Camry than the Civic? So, right, doing exactly what we just said. Big number divided by small number minus 1. So Camry and Civic, looking at those numbers. All right. Civic is 325. Camry is 423. So 423 is the big number. Divided by 325 minus 1. 0.3015. Now be aware you can leave this as the probability. I know it says percent. That's perfectly fine for me if you leave it as the probability, or again, convert it to the percentage, but it's the same. What percent smaller was the sales of the Ford models than the Honda models? So percent smaller, so that's percent decrease. So small number over the big number, we have Ford and Honda. So the the Ford models are there and the Honda models are here. So we can notice, right, that the Ford models are going to be less because they're further to the left. So I know that the Ford is going to be the smaller numbers, which is 286, 328. All over 325 and 405. So 1 minus 614 all over 730. That gets us 1589, aka 15.89%. So percent increase, percent decrease. Again, it's really just about paying attention to what is being asked in the question, right? In part A, we were asking for a percent of the total. The part B and C we're asking, right, an increase or a decrease. So pay attention to that. Example. An exercise machine with an original price of $860 is on sale at 12% off. What is the discount amount and what is the exercise machine's sale price? So if something is $860 and it's 12% off, so again, in order to deal with percentages, multiply by 0.12. That gives us 103.20. And that's the discount price, right? Discount amount. Sorry, not price. That's the discount amount. In order to find the discount price, we simply then just do 860 minus the 103.20. Which gives us 756 and 80 cents. All right, and that's the actual discounted price. Now, be aware, we can also do this, right, in order to find the discounted price. If something is 12% off, we talked about this before, that means it's actually 88% of the original amount. And that, of course, would also result in 756.80. So that's another way to do it, all right? Subtract it from 100 in order to find that value. This year, 2,250 students registered at Golden State College, an increase of 12.5% over last year. How many students are registered at Golden State College last year? So let's start with X equals the number of students registered, all right, at Golden State College last year, right? And so now it's important to understand, okay, so a 12.5% increase. So remember that 100%, aka 1, represents the full amount. So an increase would be 112%, 12% on top of the initial 100%, which means that's 1.125, right? That is 112.5% of last year's enrollment, which we're calling X, right? With percentages, it's always multiplication. That then became this year's registration of 2,250 students. And this is the biggest thing, okay? This is how you identify an increased percentage. Because now I go to solve this, right? And I simply just divide. Which gives us 2,000 students. Now, I want to show the thing that people often do, which is a mistake. Do not. The common technique I see is that people are like, "Oh, well, let's go 2250 and multiply that by the 12.5%. That gets us 281.25. Okay, now already I know this is wrong because this is people. All right, you can't have a decimal, right? This isn't an average, right? It's not the average number of people in a household type thing. Okay, this is the actual number of students. So this has to be an integer. So already I know this is wrong because I got a decimal here. That's bad news. All right, but okay, if I continue and then everyone's like basically exactly what we did last time. Oh, well, let's do 2250 minus 281.25. This gets us 1968.75 students. Right? Notice, all right, this is the wrong answer. Okay? You cannot do increase and decrease by just subtracting, okay, that percentage off. It's super important that you have to remember that an increase was over 100%, which is why we have this, all right, in the calculation. It is 1.125. All right, so you can't just do it, all right, this alternate way. So I really want to show people what not to do because I see this often and it's a flaw in logic on multiple levels. All right. Just a couple of basic things about income tax. Just because this is something that everyone does their entire lives, all right? And the you want to be able to understand the basics. You don't want this to be like completely what's the word? Oh, mystery, like a black box. You want to understand the basics of tax. So, all right. Again, income tax, right? Basic concept is collected by the government to fund services and programs. Federal income tax is then a percentage of your taxable income. All right. So our whole idea is how do we find our taxable income? All right. Starts with your gross income. Gross income, right, is wages, tips, interest, all right, dividends from investment, unemployment compensation, profits, rental income, game show winnings, all kinds of stuff. Your adjusted gross income or your AGI, all right, is your gross income, all right, subtract certain allowable amounts known as adjustments. All right, the adjustments are various untaxed portions, all right, contribution to retirement, savings plan, interest on student loans, all right, and then some self-employment costs. Then, all right, additionally, after we find our AGI, all right, which is just your gross income minus adjustments, then you find your taxable income, which is your AGI minus deductions. Deductions are two ways. The standard deduction, which is a lump sum set amount, okay? Or you have to itemize it. And it's whichever of these is the greater. All right? So if you itemize, this is much more complicated, all right? But mortgage interest, state income taxes, property taxes, contributions, medical expenses exceeding a certain percentage. All right. And if whichever one is larger, that's the one you use. So they do give you that benefit. Now, most of the time, again, you have programs and things like that to help you. I just want to identify some basic concepts just so you understand approximately what's happening. So, Angelo earned wages of $63,500 and received $1,850 interest from a savings account and went on a game show and won $15,000. All right, contributed, and then other stuff. So, Let's start with gross income. Right? So we talked about it. Wages. All right. Your job, your main job, that's where the majority of this will come from. Then, if you have significant amounts of interest actually in savings accounts and things like that, and if you are lucky enough to actually be on a game show, oh, look. All right. So our gross income for Angelo is $80,350. Then the AGI, all right, adjusted gross income, right? That's the gross income, all right, minus the adjustments. So our 80,000, okay, then, all right, contributed $7,800 to a tax deferred savings plan. And this is what you would pay into your IRA and things like that, your retirement. So at this point, just has this $7,800. So that gives us, all right, now we're at our AGI. Lastly, our taxable income. So AGI minus the deductions. So in order to do that, so we know our AGI, right, is the 72,550. And then basically we identify our standard deduction. And we compare that to the itemized deduction. So, all right, it states standard deduction 12,550. All right. Then we have interest on home mortgage was some amount, property taxes, state taxes, charity. So we take all those values, all right, and we're going to sum all those up and see what those become. Because all of those are the itemized deductions. And notice, all right, whichever is the larger. So clearly, we see that the itemized value is the larger of the value, and that's the one you choose. And that's the basic concept. If you pay someone to do your taxes, be aware, right? When you do itemized, they charge you more. So now again, highly recommend lots of programs out there to do your taxes on your own. And so then that results in a particular amount of taxable income. And then this is the percentage that breaks it down, right? Approximately the first $20,000 you make, gets taxed at like 10%. And then the next, 50,000 you make gets taxed at 15%, and then et cetera. And it keeps going up. So just basic concepts. Want to introduce everyone to the idea of taxable income. All right. So simple interest. Simple interest, without a doubt, is, all right, the most straightforward type of interest that we are going to look at. It will always be identified as simple interest, or if there is a lack of noting of compounding, all right, we will imply that it's simple interest. But most of the time, it is directly told straight out, it's simple interest. The formula is very, very basic. All right, simple interest is known as interest only on the principal. I equals PRT. P is the principal, all right, the initial amount invested. R is the interest rate, all right, this is a decimal, and this is always going to be annual interest rate. Annual meaning yearly. Because of that, that also means that T is time and always in years. So that's the biggest thing. We always have, because we have R as annual interest rate, T is always in years. And then a general concept, future value. So the future value, which we represent as A, is always the basic concept of the principal plus the interest. Now, notice I have a little adjustment formula here, but that's basically all I did is take the PRT formula and I plugged it in for I. So you really only need to know I equals PRT. And this concept basically we use for multiple situations because by definition, future value is your principal plus your interest. That's what future value is because it'll be both of those together, which is the sum total of your money in the future. All right, let's look at some examples. To start up a new photography business, Taylor is borrowing $18,000, which she intends to pay back in 16 months. Her bank is charging her 9% annual interest on the loan using simple interest. So again, explicitly stated. Once you have simple interest, right, I'm going to write out I equals PRT. And then it's just a matter of identifying the pieces of information. All right, so I, that appears to be, right? So questions are, how much interest will she pay the bank? How much will she pay back totally? So interest, that's what we're looking for. And on the second question, right, we are looking for future value here. That's what this one's going to be looking for. Principal, $18,000 borrowed. Interest rate, 9%. And T, time. Now notice 16 months. We have to make sure we enter that in years. So that would be 16/12 years. And then we can plug into our formula. That gives us $2,160. And then, right, that's how much interest she will pay. The future value then, right, just as we discussed, A equals P plus I. So the principal was $18,000 plus the interest, which means that Taylor will pay back a total of $20,160. Again, units are everything. Okay, but good news, most of our units are going to be dollars here in the finance section. You plan to save $2,000 for a trip to Europe in 2 years. You decide to purchase a CD, certificate of deposit, and pay the bank's simple interest with 4%. How much must you put in the CD now in order to have $2,000 in 2 years? Once again, all right, I equals PRT. But notice, okay, what we're looking for, how much will we need to have, all right, in order to have $2,000 in the future, right? That means that's the future value, that 2,000. All right, so our interest, that means that's unknown. All right, the principal, that guy's unknown. Interest rate is told to be 4%, and time was 2. And remember, that's in years, so it never hurts to put that unit. Now notice, it doesn't seem like I have enough to do my I equals PRT formula. This is why we had the other one. A equals P plus I. So A equals P plus. Now let's put our PRT formula in there. And now I think I have enough information. A is 2,000. P plus P R 0.04 and T 2. This I think I can solve because, right, this is 0.08 is 0.04 times 2. So that gives me, I guess let's write this out one more time just to emphasize this. P P plus 0.08p, that becomes 1.08p. Just to emphasize, I see people mess that up because they're like, don't know how to add variables with decimals, right? All the same algebra we've been doing and you have done most of your lives. Once you have that, then divide by 1.08. Which gives us P equals 1851.85. Right, so we need to put in $1,850-ish now in order to have $2,000 in 2 years with simple interest. Okay, if a person accused of a crime does not have sufficient resources, he may pay a bail bondsman to post his bail in order to be released till trial is held. Assume the bondsman charges $50 fee plus 8% of the amount. If the bondsman posts $20,000 for the trial that takes place in 2 months, what interest rate is being charged by the bondsman? Notice this one didn't say, all right, simple interest, but all right, it is implied usually because of lack of discussion of compound interest, which we're going to talk about in just a minute. So I wanted to show everyone that. So, all right, so let's start IPRT. Now, most of the time, simple interest is explicitly stated. Okay, $20,000 bond, interest rate of 8%, and 2 months. That means, again, 2/12 years. All right, so that comes out to 266.66. All right, and then the important part here. My apologies, 266.67. All right. So then the important part, a $50 fee on top of that. That's what the actual interest becomes, which then makes this the actual interest, right, is $316.67. So this one, all right, and then we're trying to identify what interest rate, all right, is being charged, which means now we need to solve this backwards, I equals PRT, to find what the actual rate is, because this flat fee, all right, even though they said it was an 8% interest rate, that flat fee really increases the interest quite a bit. And that's the big thing, right? No matter what interest rate you are told, watch out for flat fees because that's what really boosts it up. So now let's solve this backwards. Same information, right? 20,000, but now we don't know rate and it's still 2/12, right? 2 months. And then divide by 3,000 and some change. That gives us 0.0950, all right, aka 9.5% interest. All right, so even though it was claimed to be 8% interest, that flat fee jumped it up another 1.5%. And the longer that goes, right, all right, That's the big thing. Short term, that's a big jump. So watch out. One of the big things to watch out for. All right. Compound interest. Here's getting closer to real world interest. So simple interest is interest only on the principal. But compound interest, all right, is interest on interest. And this is how most interest is calculated nowadays. Again, very similar information. P is principal. R is annual interest rate. T is time in years. Our new value here, all right, is N. This is number of times that occur per year. So just for a few examples, if something occurs weekly, N would be 52. If something occurs daily, N equals 365, right? If something occurs monthly, N equals 12, right? And there's only a few more examples, but those are the main ones. So we have our formula, and notice a future value again. Now these are not too bad. The biggest thing is just make sure in your calculator, all right, you follow the calculations, and whether you're using a TI or Casio or whatever, all right, that you can input this into your calculator properly. So if Julia deposits $5,000 in an account that has an annual interest rate of 6% compounded quarterly, what is the value of the account in 5 years? Compounded. Soon as it mentions compounded, that's what should indicate one of our compound formulas, not the simple interest formula. What indicates this one particularly is compounded quarterly. So when it represents a number of times compounding per year, that's this formula. So that tells me A equals P 1 plus R all over N to the NT. And so let's identify our information. So, right, what value's in the account? That means we're looking for the future value. We deposited $5,000. We have an interest rate of 6%, 0.06, 5 years. And again, this has to be years as well, so that's correct. Compounded quarterly. Well, how many quarters are there in a year? 4. So that makes that N. And then this is a matter of just inputting. Now, important part, all right? Everyone's calculator is different, so I used to run through the calculator commands, but it only ever helped those with my calculator. So I'm happy to help you with this, but you need to verify that these calculations, you can do them in your calculator, whatever calculator you have. Oops. Now, I'll give you some basic I'll give you some basic shortcuts. First of all, I definitely recommend you doing this inside calculation first. All right, similarly, this calculation in the exponent. Because your calculator, all right, sometimes does order of operations exactly as you type. Well, always exactly as you type it. And that's not what you mean. That's just what you typed. So it's important to understand what you actually mean. Your calculator is a tool, and it's only as good as the operator of that tool. So simplify the stuff in the parentheses. Do those small calculations, all right, before you input it in the calculator. Now, ideally, you can input this, all right, what's remaining, this entire command in the calculator all at once. But if not, do this as the first piece and then multiply it by 5,000. Now, I'm writing lots of decimals here just so you can follow the command, but typically I wouldn't write that. Just keep the values in your calculator, all right? And then just keep doing the operations with that exact answer. The big thing too, all right? You want to be as precise as possible, all right? rounding error is the only real issue. So do your best to avoid doing lots of sub calculations and messing up. All right. And ending up with a number that is several dollars, all right, off, let alone cents. All right. Think about banks, right? If someone was shortchanging you $5, that's actually a lot of money consistently. And for banks, that ends up being millions of dollars, right? Because they have like thousands and thousands of accounts each. If they were either shortchanged or getting shortchanged several dollars per account, that makes millions and eventually billions of dollars. So precision is important here. All right, the other type of compound interest is continuous interest. And this is actually how most interest is calculated. All right. Because compound continuous interest, it's essentially the concept of interest being compounded. The kind of equivalent number is like 3 or 4 times a day. Now, continuous means it never stops compounding, but we could actually do calculations with the compound n times per year formula. If you put in 4 times 365, you actually get a number that's pretty close to this formula. So, um, same basic concepts. P is principal, A is future value, R is annual interest rate, T is time in years. The new value here is this symbol E. All right. In your calculator. All right. You can see it. All right. It's like the pi button. It's in several spots. And the basic number for E, 2.718281828. All right, and that goes forever. 1828. E is what's referred to as the natural number. All right, it is the exact value, okay, of exponential growth. And this is a value that was observed actually in nature, all right, when they saw things that grew exponentially, things like bacteria. All right. And they found that this translates perfectly to relative growth rates for money. All right. It's also a value used in decay nuclear materials. Very, very important number, very, very commonly used number. All right. So if $1,000 is invested at an annual interest rate of 8% compounded continuously, so again, it straight out says compounded continuously, indicating this formula. What amount will be in the account after 2 years? All right, so again, looking for a future value. $1,000 invested, 8%. All right, and T is 2 years. So when we plug it into our equation, again, some notes. You should be able to find this in your calculator. All right, walk through. All right, if you need videos on that, Google. And just a couple things. So again, the 1,000, and then I really recommend E is a particular value. Do that stuff in the exponent first, right? 2 times 0.08. Then do this calculation. And then that gives us, all right, $1,173.51. But again, E is an irrational number like pi. All right. So just like you should always use the exact value of pi, not 3.14. find E in your calculator, all right? Type it in, just the value, and make sure it comes out to 2.718281828, etc. And then you then use it, all right, for compound continuous calculation questions. All right, annual percentage yield. So this one is usually explicitly asked as well. It'll say true interest or effective interest, or more usually explicitly, it says APY, annual percentage yield. Notice this equation, very, very similar, all right, to our compounded n times per year, but notice what this doesn't have, principal. The whole idea of this is this identifies what the actual interest rate is, the true interest rate, all right, regardless of what you're actually told. And so it takes the principal and the dollars out of it, calculating only, all right, the compounding. And so that's actually a really nice, like, breakdown of an equation. This is the whole thing when they tell you APRs, right? That usually those are lies. If they say at 0% APR is like the most famous one, because a 0% APR does not mean 0% interest. Definitely not. Okay, so just be aware of that stuff. So, a savings and loan bank wants to offer a CD with monthly compounding that has an APY of 7.5%. What annual rate compounded monthly should they use? And notice we don't need that much. All right, so it says a 7.5 APY. All right, we are trying to find, all right, the compounding rate. And then compounded monthly, right? If I compound something monthly, that means how many times per year? 12. And then we can use our APY formula. Okay, so this we'll walk through a little bit slower. So I have this equation to solve, right? And I have that my variable is inside, right, parentheses with exponents and all kinds of stuff. So with our algebra, do the simple things first. Add 1 to both sides. Now here's the big thing. This is to the 12th power. So how do you get rid of a 12th power? So remember, squaring. X squared equals 4. How do you get rid of a square? Square root. Similarly, how do you get rid of 12th power? 12th root. Now, in the calculator, all right, a shortcut to this, instead of doing 12th root, if you recall, all right, from your algebra, square root is equivalent to the 1/2 power, which means that if I do this to the 1/12th power on both sides, that's the same. So on this side, right, 12th power, 1/12th power, that just becomes 1 plus r over 12. On the other side, 1.075 to the 1/12th power. And again, I'm writing this out just so you can see all the values, because we want to be precise. Got to be precise. Can't be rounding this off all the time. Keep the value in your calculator. And then now some easy things. -1. And then multiply by 12. Which gives us 7 1/4%. So this one is more interesting. This one is more about the solve, all right, and how to get rid of a 12th power. That's a 12th root or whatever root that you would need to get rid of. All right, one last big concept here. So annuities, because what we've basically dealt with up till now is fixed value interest. All right. You have a particular lump sum and then you invest it and see how much you have at the end of that time period. Well, that's not very realistic. What's much more realistic, all right, is car payments and house payments and retirement investments. People paying small amounts over long periods of time, right? We have lots of time in life, and at no point in my life am I going to be holding on to $100,000. Okay. So what we tend to do is pay in small amounts over time to create that $100,000. That's what's known as annuity. All right. Now, the equation, all right, although looks more complicated, should have a lot of familiar pieces. All right. R is interest rate, N is number of times per year, T is time in years. All right. Now we have a different value, PMT, which is payment, and future value, which we are calling FV, but we've been calling that A. So you can use either one, FV or A. So all of this should be very, very familiar. An annuity is recognizable in the question when it actually says, okay, it'll say stuff about compounding. Okay. I see compounded annually. I didn't even have to read it. Jamie deposits $2,000 annually into an IRA and earns 6.85% compounded annually. Due to a change of employment, these deposits stop after 10 years, but the account continues interest until Jamie retires 25 years later after the last deposit. How much is in the account when Jamie retires? Okay, notice depositing annually. It's all about periodic, right? Payments, right? Or deposits or whatever. That's what an annuity is. It's not lump sum. So, as always, let's identify our information. But now we have a new category, payment, right? Future value, all right, which we could call A. It's still the same. R, N, T. So clearly her payments, $2,000. Future value, that's what we're looking for. Interest rate, 0.685. Compounded annually. All right, how many times a year is annually? Once. Now, here's the big thing, okay? These deposits stop after 10 years. So she's doing periodic payments for 10 years, then something different happens there. So let's just do this first 10 years. Again, I know the formula looks a little intimidating, but it's very similar to the formulas we have been working with. Okay, so the payment, $2,000. Oops, all over in. All right, again, I can put this whole thing into my calculator as long as I know what I'm doing. All right, I'm going to do a couple of simple things just to make sure when you put this in your calculator, you don't like mistakenly put it in. So again, solve inside these parentheses first. All right, solve that exponent. Simplify in a few areas before you input it. The only issue with these problems usually, okay, is people struggle to put this in the calculator. They have all the right information. They identified it great, right? Which is definitely the focus that I want you to focus on. But then I was like, the calculation, did I see this mistake? And it shouldn't be a mistake. All right. Then this actually, what we have now, we should be able to easily put in our calculator, but we could simplify it down one more step just to make sure. Now again, when I do this, I'm I definitely do not write this many steps, but it just never hurts. All right, to have more steps than you need. All right. So simplify that, and this is what we should end up with. 27,000 and some change. Okay. Now, here's the big thing. Now notice, right? But right after a change in employment, the deposit stops. So that's just what happened. That's how much money she has after the first 10 years. But the account continues to earn interest until she retires 25 years after the last deposit. How much is in the account when Jamie retires? Now, this has basically become a lump sum. This is going to sit here and accumulate interest for the next 25 years. This now becomes our equation because that is a principal value, a lump sum, and then just accumulates interest compounded annually. So we still have all the same information. All right, but now we have our principal value there, right? Our interest rate is still the 6.85%. Our time is now 25 years, and it's still being compounded annually once per year. So now let's calculate this again. Now, since I've gone through this a few times, I assume you can handle that calculation on your own. And then now notice, right? $2,000 a year, okay, for 10 years. That's $20,000. This whole thing, 35 years later, that's $143,000. That's the concept of how much interest you can accumulate. And 7%, that's not unreasonable. Compounded annually, actually, that is unreasonable. That means this is even a lower amount because things compound much faster than annually. Okay. Now be aware, sinking fund is is the same thing as an annuity. This equation that I have written right here, it is exactly this equation. It's just solved for payment, all right, instead of future value. So notice, all right, it is the same equation. All right. I put it here, but I don't want it to confuse you. We really just have one equation, just solve one is solved for the future value, one is solved for the payment. But it has all the same information, and you only need one equation. You could just solve it at the very last step. So let's look at an example. A company estimates that it will have to replace a piece of equipment at a cost of $800,000 in 5 years. To have this money available in 5 years, a sinking fund is established by making equal payments into the account, paying 6.6% compounded monthly. Again, here it is. Okay. Periodic payments. All right. Equal periodic payments. That's what an annuity is. So let's see what we have and let's see what we're looking for. Okay. want to have a future value of $800,000. Okay. How much do the payments need to be? That means that's what we're looking for. 6.6% compounded monthly. That means there are 12 months in a year, and we want to have that money available in 5 years. So we can use either equation, but since we have the formula for the sinking funds equation, all right. So again, you should be able to simplify this down again yourself now, piece by piece, just like we did last time. And this ends up being, all right, $11,000 per payment. Okay. So that means $11,000, right, per month. Now, here's the interesting one. How much interest is accumulated on this annuity? So we know that we resulted in $800,000. So in order to actually find the interest, that's our $800,000. That's what we ended up with at the end of 5 years. Well, our payments, right, 11,290, that's how much we were paying every month. And how many months did we have in the 5 years? 60 months, yeah. It was 12 times 5. I was blanking there for a minute. And so that means that we simply have to do this calculation and we can actually see how much interest was accumulated. And notice in 5 years, we accumulated over $100,000 of interest. The whole idea of creating a sinking fund instead of just straight saving, okay, $800,000 in 5 years, you put it into this account that grows your money. All right. So we only had to put in, we still had to put in a lot, $680,000, but we didn't have to put in all of it. All right. The money grew over time. And that's the use of an annuity. All right. All kinds of good stuff with finance math. You have yourself a wonderful day and enjoy the activities.